So, a reminder before the lesson begins, make sure you're taking notes and you're listening and watching for the keyword or phrase. Let's get to it. So, today we're going to be talking about combining like terms. This is the third lesson in Unit 4, where we're talking about expressions, equations, inequalities, and circles. Our aim for today is how can we combine like terms to simplify algebraic expressions. We've talked about translating algebraic expressions and evaluating algebraic expressions in lessons 1 and 2, so definitely go check those out. Today is just day 1 of combining like terms. Depending on how we feel, we'll have day 2 and we have more practice after that. So the first thing we want to do is go over some important vocabulary words and phrases that are going to be important when combining like terms. A lot of these problems you are going to see are going to say to simplify. Basically, what we're going to do is we're going to be making an expression easier to understand and evaluate. Like terms are going to be terms that have the same variables that are raised to the same power. So if you look at the examples provided, we have in our first section, we have 4x, 7x, and 9x. If you noticed, they are all with the same variable. They all three of them have x. And if you think about it, the exponent is to the first power. So all of these exponents are all the powers is 1. So even though your coefficients, the value in front of your variable, are different, just because you have the same variable and the same exponent, that means they're going to be like terms. Same thing when we have constants. Constants are values that aren't going to be changing. So we have 15, 36, and 2. None of them have exponents. None of them have variables. They're all like terms. Then we have x to the second power. The power is, in all of these terms are going to be 2, and we have different coefficients, which that's okay, but we have the same variable raised to the same power. So x squared, x squared, x squared. Each of these are going to be like terms because they're following that same characteristic. Terms that have the same variable that are raised to the same power. So there are a couple of steps to follow when combining your like terms. You want to identify your like terms first. Do you have a constant? Do you have x squared? Do you have y? Do you have x? What variables are involved? You want to make sure you're circling the terms and the sign in front of it. So let's say I had a negative 9x plus 4 minus 3x. When you circle your terms, you have similar terms here and here. You want to make sure that you're taking the negative in front, the negative in front. Even if you have your 4, positive 4. That is what goes with the term. So we have negative 9x, positive 4, and a negative 3x. We're separating the term and the sign. Step number 2, make sure you have the same variables that are raised to the same power. Again, making sure they're like terms. Sometimes you might not even have like terms and you can't combine. But you also want to know step 3, constants are always combined. And then another step to remember are that integer rules with positive, negative, multiplying, dividing, adding, subtracting are going to be very important, and you have to follow your order of operations. So a lot of things that come into play from the past units that we've had. Okay, let's try the first problem. So as we said before, the question is asking you to simplify. So the first step, I want to make sure I'm highlighting or circling the term and the sign if they're like terms. So I know I have my x and I have constants. So I have 9x and negative x. And then I have -2 and +7. So what I usually do also to help me kind of separate everything out, I make a table. So I know my like terms are going to be x, and I usually have my constants, which I really just write CON for constant, because I don't want to write a C just in case if I have a variable in there with C. So I'm going to write everything down in my table. So here we have a positive 9x. If there's no sign in front, it's going to be positive. So we have positive 9x. We have a negative x. So I'm just listing them out vertically. My constants are -2 and a +7. So what I'm going to do is I'm going to combine them vertically. So if you think about the different values I have, 9x minus x, technically it'd just be -1x. So if I have 9 x's and I take one away, the only thing I'm left with is 8x. If you forget, you can actually draw out 9 x's. What happens if I take one away? I'm going to erase. I'm left with only 8. So I have 8x, and that's a positive 8x. Here we have -2 plus 7. If I add 7 to -2, I'm going to get a +5. So in order to get my simplified expression by combining like terms, I would get 8x plus 5. If you do not want to use the table way, you can rearrange your expression. So I would want to keep my like terms together. So I have positive 9x minus x minus 2 plus 7. And then I would just continue to break down, combine these, and combine my constants. And again, you would be left with 9x minus x. I'm left with 8x. And then -2 plus 7, I'm left with +5. Same answer. Either way. Okay. For number 2, it's a little trickier just because we have that subtraction between. What we're going to do is imagine there's a -1 and we want to distribute that -1 to both terms inside the parentheses. So in order for me to do that, I'm just going to rewrite my next steps and then start combining my like terms. So I'm going to rewrite everything. Again, once you become a master at this skill, you might not even need to write this all down. But it's really good to help practice doing it. I left the 1 in front of the x. You don't have to. You can just leave it as x. But for me, it helps me remember there is a 1 in front. So now I can look for my like terms. I have 7x, -1x. I have my constants, +3, and a -4. And depending on how you like to separate your table, or if you want to write it just in groupings, you can do that as well. So I have my table, constants, and x. I have +7x, -1x. Then my constants, I have +3, -4. And I'm going to combine all of those vertically. 7x minus x, I'm left with 6x, positive. +3 minus 4, I'm left with a -1. And that's my expression, 6x minus 1. And there you have it. For number 3, Pause the video here. Try this one on your own, whether you're using switching everything around in groups or if you're using the table. Come back and check your answer. So here we actually have 3 different like terms. We have x, we have our y, positive 3y, negative 9y, and then the last term, or the last like term, is positive 2x squared. Now here we don't have another positive 2x squared, but it can't be combined with either of these, so it is a loner by itself, but we're going to hold on to the 2x squared. So here I'm just going to rearrange things. I'm going to move it around since I've used the table before. So I'm going to keep my negative 2x here. I'm going to move my negative 4 over. Again, you're taking the sign with you. I have positive 3y minus or negative 9y. And I'm going to leave the positive 2x squared here. Okay, so here we have our x's. Let's simplify and combine those. Negative 2x minus 4x. I have a negative, following integer rules with our coefficients. Negative 2 minus 4 is going to give me negative 6x. Then we have positive 9y, positive 3y minus 9y. So here we're going to subtract 9 from positive 3. We're going to get negative 6y. And then we have all by itself the lonely 2x squared. If you wrote it this way, if you wrote it 2x squared minus 6x minus 6y, or some form where your signs are going to match up and stay together, then you're okay. These are the correct answers. So either this one or this one. I mean, there could be multiple equivalent expressions, just taking the different terms and moving them around. Okay. Number 4. So number 4, it's a little bit of a challenge. So try this one on your own, pause the video, and come back and check your answer. Beware of the distributing. All right, so here we're going to distribute 2 to our negative 5x and to our negative 2y. I'm keeping those as terms separate. Same thing in the other set of parentheses. I'm keeping it separate. Okay, so I have negative 5x times 2 is negative 10x. 2 times negative 2y is negative 4y. I have plus 9y. And now I'm going to take the term outside, negative 3, and multiply and distribute to both terms inside the parentheses. So I have negative 3 times 4x, which is negative 12x. Negative 3 times 5 is negative 15. So now I'm going to use like terms, and I'm going to combine and simplify my expression. So here we have negative 10x, negative 12x. Okay. We have negative 4y, positive 9y, and then we have negative 15. So what I'm going to do is I'm going to create a table. I know I have an x, I have a y, and I have constants. So I'm going to list my negative 10x, negative 12x. My y's are negative 4y, positive 9y, and then negative 15. So negative 15 is just going to stay down here. Negative 4y plus 9y, we're going to get positive 5y. And then negative 10x plus, minus 12x, we're going to get a negative 22x. So our simplified expression would be negative 22x plus 5y minus 15. If you wrote it as 5y minus 22x minus 15, that would have worked as well. So make sure that you identify the keyword and phrase for this lesson. Make sure you're writing down any questions that you have for me, and I will see you in the next video. Bye.